Okay, so we are doing a refraction of light, and in refraction of light, we are studying that a ray of light incident obliquely on a surface separating two transparent media, its direction changes at the surface. This phenomena is called refraction. So here we are taking two medium. So upper medium, this is called optically rarer medium, and the lower medium, it is called optically denser medium. So why it is called optically rare medium? Optically rare medium means the particles, they are far away from each other. Optically denser medium means the particles, they are close together. So here we can take, for example, this is air. This is air, and this is, let me take water. Water. And this is the boundary line. It is the boundary line which separate air from water. This boundary line, so let me call this is X, Y, this boundary line, this is called interface. This is called interface. So what is the interface? Interface, it is the boundary lines which separate the two media. It separates the air from water. So it is called interface. So I take one ray of light coming from the sun or any light emitting object. Obliquely, it reaches to the interface at this point. So let me call this point as O. So one ray of light obliquely, it reaches to the point O, and it makes an angle theta 1 with the normal. And this is my normal. Normal, it is an imaginary line drawn perpendicular to the XY. Imaginary line drawn perpendicular. So this is perpendicular to this interface. This is called a normal. So the ray of light, this ray of light incident at this interface at point O makes an angle theta 1 with the normal. And because now some portion of this light, incident light, some portion, because this light has energy, this has energy. So it has energy, and some portion of the energy at this point, it is reflected back to the same air, comes from the air and back to the same air. So some portion of the energy means around 20% of energy is reflected. So this is reflected back in the same medium. This is called reflection. And this angle is called angle of reflection. Angle of reflection. And angle of reflection is equal to angle of incidence. Here the angle of incidence is theta 1. So theta 1 is equal to angle of reflection. Suppose if theta 1 is equal to 30 degree, so angle of reflection in this case, that is also 30 degree. So 20% of the incident energy that will be reflected, and remaining 80% that will enter into the second medium, that will enter into the water. So the 80% that will enter into the water, that will change the medium. So in my previous lecture, I told you that reflected light is less bright, or less intense, or less intense. But this refracted light, it is highly bright, or highly intense. highly intense. Intensity is a term which is related to the brightness of the object. So now you see carefully, this is the normal in the water, and this 80% of light energy, this makes an angle theta 2 with the normal, and this theta 2, it is called angle of refraction. Angle of refraction. Be careful while observing the angle of refraction. All the time it is taken from the normal, not from the surface, not from the surface. So this is called angle of refraction. So this was the part of my yesterday lecture. And one more thing which I discussed in my yesterday lecture, that was the wavelength. That was the wavelength. So from this animation, you can see how the wavelength of incident light changes when it changes the medium. How the, so you can see that incident light has wavelength lambda 1, has wavelength lambda 1. So how we can demonstrate the wavelength? So wavelength, that is the length of a wave. So this is my wavelength. This is my wavelength. So having this part is called the crest, and this part as the trough. So one crest and one trough, that makes 1 lambda. So from here to here, this is my 1 lambda. This is called lambda. So the incident light that has wavelength, so incident light that has wavelength equal to lambda 1. And refracted light means the light entered into the water. That is called the refracted light, that has wavelength equal to lambda 2. So now we can compare lambda 1 and lambda 2. So lambda 2 is much lesser than, this is lambda 2. So lambda 2 is much lesser than the lambda 1. So when the light enters into an optically denser medium, its wavelength reduces. So lambda 1 is greater than lambda 2. Lambda 1, it is in air, lambda 2 is it in water. So this is rarer medium, air is a rarer medium, and water is a denser medium. So when the light enter into the denser medium, its wavelength decreases. Due to the density of the material. It's the highly dense, that will reduce the wavelength. But one more term, it is called the frequency. So what about the frequency of the wave? What about the frequency of this wave? So suppose this wave was moving with a frequency of 20 hertz, means 20 cycle, these 20 cycles in 1 second, that is called 20 hertz. 20 cycles are completed in 1 second, so that is 20 hertz. If 30 cycles, this is a single cycle. This is a one cycle. One cycle means one wavelength. One cycle means one wavelength. So 20 hertz means 20 cycles in 1 second. 30 hertz means 30 cycles in 1 second. That is called the frequency. So what is the frequency? So let me take, if the frequency, I will assume, if the frequency is 20 hertz in air, means 20 cycle per second. So light, when it will enter to water, it will having the same frequency, 20 hertz. Frequency will not change. 20 hertz means 20 cycle per second. It will maintain the same frequency, but the wavelength will decrease. The wavelength will decrease, as well as the speed will decrease. The speed in the air, that is speed of light, 3 into 10 raised to the power 8 meter per second. And now in the medium, the speed will become v, that will be less than c. That will be less than c. So what are the factors which changes? So velocity changes, wavelength changes, but frequency remains unchanged. Unchanged. So wavelength changes, velocity changes, but frequency remain unchanged. So from these three terms, velocity, frequency, and wavelength. If the velocity is v, velocity in medium, which is a water in this case, frequency is f, wavelength is lambda. So what is the relation between these three? So velocity in the medium, that is equal to product of frequency and wavelength. So velocity in the medium, that is frequency of the medium and wavelength of the medium. So we can find, if we know the frequency in a medium, we know the wavelength in the medium, then we can find out the velocity in that medium. So in this case, frequency in the medium is 20 hertz in the water, and wavelength is lambda 2. So 20 hertz, 20 into lambda 2, that will be the velocity. That will be the velocity in the medium. Now, what is the velocity in the air? So velocity in the air, we can find out velocity in the air. So frequency in the air, it is 20 hertz, so 20, and the wavelength is lambda 1. So that will be the, now you see, this is equation number 1 and this is equation number 2. So compare equation number 1 and equation number 2. The frequency is same, but you can see lambda 1 is greater than lambda 2. Lambda 1 is greater than lambda 2. So V air, velocity in the air, that is greater than velocity in the medium. Velocity in the air, that is greater than velocity in the medium. So when the light enter into a denser medium, its speed lower down, its frequency remain unchanged, its wavelength also reduced, its speed also reduced, but there is no change in the frequency. So these are the few terms. For the light rays when they change the medium, means when the light do refraction. In the refraction, the light changes the medium. It can move from the rare media to the denser media or vice versa. We can study the refraction also in the reverse case, means when the light is moving from denser media to the rare media. So let me discuss that point also with the help of another concept which is called principle of reversibility of light. Principle of reversibility of light. So what is principle of reversibility of light? So let us go for that. Now my target is to study the principle of reversibility of light. So for that I will use the Zoom board. So my topic is principle of reversibility of light. Principle of reversibility of light. What is that? So what the principle of reversibility of light says? It says that, let me take the same case. We have this interface XY, and this is air here, and here it is water. This is water. So I draw a normal on this interface. So this is my normal. And one ray of light incident at this point, making an angle theta 1. And you know that it is angle of incidence, and this is my incident light. And this angle is called angle of incidence. This theta 1 is called angle of incidence. Angle of incidence. And some portion, it has energy E, energy of the incident light is E, and some portion is reflected, and about nearly 20% is reflected, and this is called angle of reflection, and this is called angle of reflection. And this theta 1 is equal to angle of reflection. This is the law of, so from law of reflection we can say, angle of incidence, that is equal to angle of reflection. And some portion that will be refracted into the medium, and this is called angle R, and this is called angle R is called angle of refraction. Now, if I place a plane mirror over here, so what will happen? The light will fall at an angle of 90 degree over here, 90 degree, okay? Or we can say the light will fall at an angle of 0 degree with normal to the mirror, 0 degree with normal to the mirror, So let me just show you the normal of the mirror. So let me take a plane mirror, and I draw a normal, So this is the normal. In our case, our light is also falling on that normal, along the normal. So what is the angle? It is 0 degree. So when the light travels along the normal, so it will retrace its path. After reflection from this point, it will go back by the same path. So the same thing will happen in this case also. The light will go back by the same path. But now little changes are there. Now this becomes angle of incidence. Now this becomes angle of incidence. Now it's not an angle of reflection, it becomes angle of incidence. So let me choose. Sorry. So this becomes angle of incidence. I can take it I, angle of incidence. Okay. And now at this point, the light ray that will go back by the same path. So this will become angle of refraction. So light will go back by the same path. So light after reflection, it will follow the same path, that is called principle of reversibility of light. Light will go back by the same path. जहां से light ने travel करना start किया था, so that was the starting point. That was the starting point. और ये उसका end point था. अब जो end point है वो बन गया starting point, और जो starting point था वो बन गया end point. So this is called principle of reversibility of light. So let me go back to the main slide. Let me go back to the main slide and discuss the next part. So now what is Snell's law? Snell's law, so we studied about two angles. First is the angle of incidence, and then it is the angle of refraction. So this is angle of incidence, angle of incidence, incidence, and this is angle of refraction, angle of refraction. Now we take sine of angle of incidence and sine of angle of refraction, and we take the ratio of these two, sine of angle of incidence divided by sine of angle of refraction. So the ratio that will give me the refractive index of the second medium with respect to the first medium. So this is the second medium, refractive index of the second medium. This is the refractive index of the first medium. So in our case, we took this was the interface XY, and this was air, and this was water. Refractive index of the water was N1. Refractive index of the water was N2. Air N1, water N2. So this was the normal and obliquely light incident. So this was angle of incidence, and then it was refracted. So angle of refraction was R. So we took sine of I, sine of angle of incidence, and sine of angle of refraction. And now we took the ratio of these two. So that will give me the ratio of their refractive index. That will give me the ratio of refractive index. So, but in just opposite order. It is sine I, so it is N2. Sine I means angle of incidence. Now that is trying to move to the second medium. Sine of angle of refraction, sine of angle of refraction, and that comes from the first medium. So you can just memorize this sine I upon sine R, N2 upon N1. This is not N1 upon N2. This is N2 upon N1. So we can call it N21. N21. N21 means refractive index. N is a refractive index. N is a refractive index. Refractive index. Refractive index of the second medium with respect to the first medium. So that is called N21. We can call this as 1 and 2 also. 1 and 2. 1 and 2, we will pronounce the same thing. Refractive index of the second medium with respect to the first medium. So this is Snell's law. Sine I upon sine R is equal to N2 upon N1, or N21 or 1 and 2. N21 means refractive index of the second medium with respect to the first medium. Likewise, this is also the same thing, refractive index of the second medium with respect to the first medium. So basically here, N is refractive index. N1 refractive index of the first medium, in our case it is air. N2 is the refractive index of the second medium, in our case it is water. We can write it in this way also. If we do the cross multiplication, so it will become sine I N1 and sine R N2. So after cross multiplication, we will get the Snell's law in this form also. This is also called the Snell's law. So if anyone asks you, write down the Snell's law. So you can write it sine I upon sine R is equal to N2 upon N1, or you can write it in one more format also. You can write this like this also, sine I upon sine R is equal to N2 upon N1. You can write this also sin I upon sin R is equal to n to 1. Or you can write this also sin I upon sin R is equal to 1 and 2. So all these are same thing. These are called Snell's law. And this is the fourth form of the Snell's law. The fourth form is n1 sin I is equal to n2 into sin R. So all these forms, they are Snell's law. So in your numerical problems, you can use any of the formula to just show the Snell's law. Now, next. But we also know that how we can define the refractive index. How we can define the refractive index. So refractive index, in our case, the refractive index is n. The refractive index is n. So how we can define this n? So refractive index is it is basically n. So what is this n? So n, we have n को कैसे डिफाइन करेंगे? n को डिफाइन करेंगे, so एक बार उसको एयर में डिफाइन करेंगे, एक बार उसको वाटर में डिफाइन करेंगे. एयर मींस रेयर मीडियम में डिफाइन करेंगे, और दूसरा उसको डेंसर मीडियम में डिफाइन करेंगे. डेंसर मीडियम में उसको डिफाइन करेंगे. सो पहले उसको एयर में डिफाइन करेंगे n को. सो n एयर क्या हो जाएगा? n एयर मींस हमारे पास n1 है. n1 is equal to speed of light in air divided by velocity in air. This is speed of light in air. Speed of light in air. And this V1 is the speed of light. This is speed of light in air. Yes, air or vacuum. And this is velocity. And similarly, we can define in water also, and having the refractive index n2, that is equal to C upon V2. This is velocity in the medium. And this is speed of light in air, same, and this is velocity in the medium. So our target is to find out n2 upon n1. So now I will divide this is, let me take this is equation number 1, this is equation number 2. So 2 divided by 1. 2 divided by 1. So I will get n2 upon n1. So write the value of n2. n2 is C upon V2 and n1 is C upon V1. So this can be written as C upon V2 into V1 upon C. So C is cancelled. So we are left with V1 upon V2. So what we got? We got n2 divided by n1. It is nothing but it is a ratio of the velocities. V1 upon V2. And we know how we can write V1. What is the velocity? Velocity in medium 1. Frequency in medium 1. Frequency in medium 1 is f, and wavelength in the medium 1 is lambda 1. And how we can write V2? V2 is the velocity in water. So frequency in the water, same frequency, but wavelength is lambda 2. So frequency will be cancelled. So ultimately, we are left with lambda 1 upon lambda 2. So what is n2 upon n1? So n2 upon n1, it can be written as v1 upon v2. ये फार्मूला भी यूज कर सकते हैं, v1 upon v2. और सेकंड फार्मूला है n2 upon n1, that is equal to lambda 1 upon lambda 2. Wavelength in the air divided by wavelength in the water. So we can use any of the formula. इसको हम ऐसे भी लिख सकते हैं n21 is equal to v1 upon v2. Similarly, we can write this n21 is equal to lambda 1 upon lambda 2. Okay, so now finally what we got, what is the relation? Now what is the final relation, final outcome of this whole discussion? So let us go for the final outcome of this whole discussion. Now we can write sin I upon sin R is equal to n2 upon n1, or we can write sin I upon sin R is equal to, we can place the value of n2 upon n1, it is equal to v1 upon v2, or we can also write sin I upon sin R is equal to lambda 1 upon lambda 2. So we can use any of these relations depending upon the situations we are facing in our numericals. Okay, so okay. So this was the about the refractive index, C, velocity of light in vacuum, V, velocity of light in medium. And finally, we solved it and we got n21 is equal to lambda 1 upon lambda 2. And because light follows the reversibility phenomena, light follows the principle of reversibility. So we can also write if n21 is equal to v1 upon v2 is equal to lambda 1 upon lambda 2. So because light follows principle of reversibility, so we can write n21 is equal to 1 n1 2. So this is called principle of reversibility of light. Light will go back by the same path, and so it is called optical reversibility or principle of reversibility of light. Okay, so if the light is going from first medium to second medium, then again it can go back from the first to second, second to first. So here we will see first to second medium, and this is from second medium to the first medium. So this is called the principle of reversibility of light. So we have only 6 minutes. Even we can take one more slide also. So let me take that also. So the point which is to be noted in, we are studying refraction of light. So in refraction, frequency does not change, but velocity v and wavelength, they changes. There is no change in frequency. Frequency of the incident light and frequency of the refracted light, they are same, but there are changes in the velocity of incident light, the velocity of the refracted light, they are changed. In the refraction, the velocity decreases. Likewise, in the refraction, the wavelength also decreases, but there is no change in the frequency. Frequency of the incident light means frequency in the air and frequency in the water, they are same. So these are some special cases. So we will discuss all these special cases in our tomorrow lecture. So for today, it is sufficient. So let me take the attendance. Aditya, Ishant, Pankaj, Simran. Okay, students, that's all for today.